So from today onwards, I will be starting the Jerry Jackson book, and I will explain each concept. But first, let's begin this video with some very introduction, which is also mentioned in the chapter 1 of this book. So the first thing we are going to learn is coulomb force. So what is coulomb force? Coulomb force is nothing but if there are two charges in a space, then they both exert some force on each other, and this force is basically called the coulomb force. So let's derive it mathematically. So let's say this is two charges q1 and q2. Okay, and the distance, and this is the distance between them. Let's call it x, and it's a vectorial distance. As you can see, I marked it with an arrow. And let's say there is our reference point O. Okay, so from this point, this is one vectorial distance, this is another vectorial distance. Let's call this distance x2, and let's call this distance x1. Okay, so we can write that x1 plus x equals to x2. Is this true? It's just a basic triangular law. You can work it out. So from this we can write that x equals to x1 minus x2. Okay, I just box it down. Okay, now what is coulomb force? That I already described it. Okay, so the coulomb force depends on the individual charges q1 and not okay, wait, comma, f also depends on q2. F has an inverse relation with the distance, and basically it's cube. I mean, how do you know that it's cube? It's actually, you can prove it experimentally. You cannot prove these things using a mathematics. It just comes from the experiment that it's inversely proportional to x cube. Okay, and combining all this, we can write that f is proportional to q1 q2 by x cube. True? I think I'm wrong here. It will be x square, right? X square, and since it's square, so I have to write a modulus sign here. Okay, so now I can write f with a proportionality constant k q1 q2 by x square. Now here comes an interesting thing. Okay, so can I write like this? F equals to k q1 q2 by, now this x, I know that I can write this x like this, is not it? That x equals to x1 minus x2, x1 minus x2, x1 minus x2 whole what happened? Okay, x1 minus x2 whole square. Now do you know one thing, that any, suppose I have a vector, a vector, this is the a vector, and the magnitude is basically mod a. So the unit vector along this direction, unit vector, unit vector, I guess. So unit vector along this direction will be what? A cap, and it will be represented like this. So overall, this has no this has no unit, and this has a unit, so you can say this is a vector because it has a value and a unit. So this is a unit vector. So in this case, can I write like this? Can I write like this, that the unit vector x minus x2 mod, it's mod, right? Okay, it is what? Let's do it this way. Not this way. Let's do it this way. This is a vector, right? And what will be the unit vector of x? This x. It will be very simple, this by mod. True? So this can be written as x. What is x? X is this. X is this thing, right? So x is x1 minus x2 divided by mod of x1 minus x2. This is true. Okay, so now see, since this thing is a force, so it has a magnitude, and the magnitude is along the x direction. Why? Because first I will considering this force. Let's say this force is F1, the force exerted by Q1 on Q2. So this thing, so this x okay, so this x cap, that means this unit vector, x cap can be written like this. So I can write like this: F equals to k q1 q2 divided by x1 x2 square, and this thing as like this. Right? Now see, there is a square term, and this is the same, this is the same term, these two are same term, and it is square, and there is another, so it will be cube. So I can finally write like this: f1, or f in general, f q1 q2 divided by x1 minus x2, let's say it's f1 x2 cube, and this direction x1 minus x2. So this is our final result. This is the final Coulomb force. So what is this k? People try to find out what is this k proportionality constant using various experiments. So k is nothing but, we found out using different type of experimental setups, k is 1 by 4 pi epsilon naught. Okay, and what is this epsilon naught? Epsilon naught is called permittivity of free space. What is permittivity? Permittivity of free space. Okay, so what is permittivity? Permittivity is like the resistance. You know, when current flow through a wire, there is some resistance, right? Similarly, when the force between two charges travel, there is some resistance in the space, right? So this resistance is called the permittivity. Okay, you can also understand this way: if the resistance is very high, that means k will be very low, right? Because it's inverse relation. And if k is very low, then f is also very low, since you can see this is a linear relation, f is equals to k something something something. So this is really linear relation. So if k is low, so f is low. So you can see, if permittivity is high, the force will be low, and it's quite obvious, isn't it? It's trivial. Resistance is high, then the force will be low. So in this first video, we just explain the Coulomb's force explicitly. I hope you understand, and if you have any question, you can ask me in the comment. In the next video, I'm gonna discuss about the electric field. Okay, so as of now, thank you for watching.